Today we're going to talk about finding all 6 of our trig function values when we only know one of them. So open your Inspire document with that name. And I just remind you on the second page that it's really all review, pulling everything together that we've already learned. So you're going to be asked questions like this one. If sine theta is 5/13 and theta is in quadrant 1, find the rest of the values. I broke it down into steps for you. So step 1 is to write down all 6 trig functions and be organized about it, putting reciprocals next to originals. So let's do that. Okay. First trig value I ever learned was sine. To its right, I'm going to write its reciprocal cosecant. Next one, cosine. To its right, the reciprocal secant. Last one, tangent. To its right, cotangent. All right. Step 2. Use the information you were given to figure out what quadrant you're in. So to do that, you're usually going to need to draw your little all said triangles cry picture, but for this problem they gave us that we're in quadrant 1. That means all of your answers are positive. I put little positive signs down, even though it's not necessary, but it's so that I keep things straight, especially when some are positive and some are negative. Step 4. One of the big ideas is that when you see trig in a fraction, you still draw right triangles like the good old days. I have sine in a fraction, so I'm going to draw a right triangle and label one of my angles theta. And then when you have a right triangle and trig, you have to remember your good old friend SOHCAHTOA. So, SOHCAHTOA, sine is opposite over hypotenuse, cosine adjacent over hypotenuse, tan opposite over adjacent. I was given sine is 5/13, so that means the side opposite theta is 5, I label it, and the hypotenuse is 13, I label that. Alright, so now you can do a Pythagorean theorem quickly or know your Pythagorean triples to find the third side. 5, 12, 13 is a Pythagorean triple, or do the theorem and get 5 squared plus 12 squared is 13 squared. Okay, so now that I have those sides labeled, I can do SOHCAHTOA and write my answers. Sine opposite over hypotenuse is 5/13. Flip it for its reciprocal cosecant. Cosine adjacent over hypotenuse is 12/13. Flip it for the secant. Tan opposite over adjacent 5/12. Flip it for cotangent. And it really is that easy. Use SOHCAHTOA to find the first 3, flip them for their reciprocals, and you're done. All right, let's do one more that's maybe a little more complicated because you have to do more work, and we have square roots in there. So here we have secant theta is negative root 13 over 2, and sine theta is greater than 0. Okay, first thing I'm going to do is write down all of my trig function values with their reciprocals next to them. So sine cosecant, cosine secant. They gave me that secant value, so I'll fill it in right away so I can get at least 1 point. Tangent and its reciprocal cotangent. Alright, now figure out what quadrant you're in. All said triangles cry. Secant's negative, which means its reciprocal cosine is also negative, so I can't be in 1 or 4. Sine greater than 0 means it's positive, so I must be in quadrant 2. So I put positive signs next to sine and its reciprocal, and everything else, every other answer must be negative. Okay, trig plus fraction, draw a right triangle, and use SOHCAHTOA to label it. Well, I don't have a SOHCAHTOA, but I have a secant of root 13 over 2, which is the reciprocal of cosine. So cosine must be 2 over root 13, which tells me the adjacent and hypotenuse sides. So the side adjacent theta is 2. This hypotenuse is the square root of 13. Now you do a Pythagorean theorem to figure out the length of the third side. So leg squared plus leg squared is hypotenuse squared. 2 squared plus leg squared is root 13 squared. 4 plus leg squared is 13. Subtract 4, leg squared is 9. So the leg must be 3. Okay, now that your triangle is filled out, do SOHCAHTOA to find the other sides and the reciprocals. Sine, opposite over hypotenuse, 3 over root 13, clean it up because you can't have a square root in the bottom. and you get 3 root 13 over 13. Flip the original 3 over root 13 to get its reciprocal. Cosecant root 13 over 3. Cosine is adjacent over hypotenuse, so that's 2 over root 13. Clean it up, because you can't have the square root in the bottom of a fraction. And you get negative 2 root 13 over 13. Flip that, or they gave that to you for your secant. Tangent, opposite over adjacent, negative 3 halves. Flip it for cotan, negative 2/3. And really, that's it. So it's review of everything you've ever done with trig in one big problem.